Okay, so part 2. Alright, so now let's take a look at another example. Okay, so let's do potassium sulfide and barium chloride. Okay, so again we have, over here we have potassium ions and sulfide ion. Over here we have barium ion and chloride ion. Okay, so do our crisscross, right? So switch partners, right? So you're going to put together potassium and chloride, so that's just KCl. And then barium and sulfide, they're also 1-to-1, so it's just BAS. KCl is aqueous, right? So that's number 1 in your solubility rules. And barium sulfide is also aqueous, right? Because our rule number 3 says sulfide should be solid, but barium is an exception. So actually they're both aqueous. So this one would be a no reaction. So typically we wouldn't have to, right, we wouldn't have to balance it, right? So, but I thought I'd go ahead and show you why it's a no reaction, right? So think about what happens if all 4 of these are aqueous, right? So I can put a 2 here. That makes it balanced. Now, if everything is aqueous, what happens? If everything is aqueous, then everything breaks up. So 2K plus sulfides, right, plus Ba2 plus aqueous plus 2Cl minus aqueous yields 2K plus 2Cl minus, right, plus Ba2 plus and S2 minus. Right. So now look, everything is a spectator. You have your 2K plus here, you have your sulfide here, you have your barium here, and your chloride. So then there is no, right, no net ionic equation. All right. That's why it's a no reaction. Okay. So that's the concept behind that. Even though I don't typically ask you to go ahead and break up the ions, right? If it's a no reaction, usually just put no reaction and then it's done. Right? But I wanted to show you why it's a no reaction. Right? It's a no reaction because everything is aqueous. And everything breaks up, so then everything's a spectator. And then everything gets canceled out. Okay, good. Okay, so for the last one, I want to do an acid-base reaction. So all right, so let's react together. Let's do lithium hydroxide, our base, and we're going to react it with H2, let's see, H2 SO4. Okay. Okay, so same thing, right? So we have our Li plus and our OH minus, and we have our H plus and our SO4 2 minus. Okay. Do our usual. Okay. Lithium goes with sulfate. Right. So Li is a 1 plus, sulfate's 2 minus, so we do our crisscross. So Li2SO4 and H with OH makes water. So lithium sulfate is aqueous, right, because of rule number 1 about lithium. Right? Lithium is a group 1A cation. But you could also look at sulfate in rule number 2. Right? Sulfates are aqueous, and lithium is not an exception. So it's acid-base reaction. Now we want to balance it. We made water, so the reaction will occur. So we're going to balance it. We have 2 lithiums here. So we're going to put a 2 here for 2 lithiums. And then now we have 4 hydrogens. 2 and 2 is there. So we're going to put a 2 here to make 4 hydrogens. Okay, so now comes the total ionic equation. So 2 lithiums, aqueous, and 2 hydroxides. Okay. Now your sulfuric acid. Alright, so those are all our ions there. Alright, then the right side, 2 lithiums and sulfate. And then water, because it's liquid, we're going to leave it alone. We're not going to break it up. Alright, so our spectators, lithium cancels, and sulfate cancels. So then our net ionic equation is our 2OH negative plus 2H plus yields 2H2O liquid. And then you can reduce your 2's. Right, reduce. And you end up with OH minus plus H plus yields H2O liquid. And that's it. Okay. Alright, so actually we'll do one more. I want you to try and do this on your own. Okay. So I'll go ahead and get you started. Okay, so react together. Ammonium carbonate and copper 2 chloride. Okay, so go ahead and stop the video and try and do it on your own. But I'm going to go ahead and keep going. So pause your video and so that you can try it on your own. All right, to see if you get it right. Okay, so over here we have ammonium ions and we have carbonate ion as well. In this side we have copper 2 ions and chloride ions. All right, so do your crisscross. Okay, so ammonium goes with chloride. Okay. So that's, since it's a 1-to-1, it's NH4Cl. And then copper goes with carbonate. It's also a 1-to-1 again. So it's a CuCl3. Alright. Okay, let's check your solubility rules. Ammonium chloride is aqueous because of the ammonium. Alright, rule number 1, ammonium is aqueous. And copper 2 carbonate is rule number 4, right? Because neither of these fit in any of those 3 rules. So rule number 4 means it's a solid. So there's our precipitate. Okay, so this reaction will occur. Okay. So we're just going to balance it. We have 2 ammoniums and 2 chlorides. We just put a 2 here, and that takes care of it. All right, so our total ionic equation. So just like we have here, you can see those. It's the 2 ammonium ions plus carbonate plus copper 2 aqueous plus 2 chlorides yields 2 ammonium ions plus 2 chloride ions, and then our copper 2 carbonate stays. Okay. Now cancel your spectators, the ammoniums, and the chlorides. So then the net ionic equation is what's left over. Carbonate and copper ions yields copper 2 carbonate. And that's it. Okay, so if you check at the end of the chapter, you'll see more of these to practice at the end of chapter 7. So practice a bit more and see how you do. Okay, see you in class on Wednesday.